Alright kids, it's Petey the Polygon Plantain here to talk to you about some angles and polygons. Whoa!
The first vocabulary term is the diagonal of a polygon. That's a segment that connects any two non-consecutive vertices. So here we have two polygons, a quadrilateral and a pentagon. In our quadrilateral, if we were looking at each of these vertices, A, B, C, and D, a consecutive vertex with vertex D would be A or C. A consecutive vertex with vertex A would be D or B. A consecutive vertex with vertex B would be A or C. But to create a diagonal of a polygon, we want two non-consecutive vertices. So that would be like connecting vertex B and D, or A and C, as you can see with this red segment right here. Same thing over here with this pentagon. If I were to connect point I and G, or vertex I and G, I create a diagonal of this given pentagon, segment GI or IG. If I were to connect vertex I and F, or points I and F, I would create a diagonal of this pentagon, segment FI or IF. There are several more in this given pentagon, but I just wanted to label a few just to give you some examples. Now, the Polygon interior angle sum theorem says the sum of the interior angle measures of an n-sided convex polygon is equal to the quantity n minus 2 times 180 degrees. So let's break this down. This theorem is giving you the sum of the interior angle measures. So if I were to add up the measures of all of these interior angles, that's what this formula is giving you. Next, it's an n-sided polygon, meaning that n is just the number of sides. So here in this particular figure, we have 1, 2, 3, 4, 5 sides. So if I wanted to figure out the measures of all of these angles added up together, I would plug in 5 for n in this formula. And you see, if I were to do that down here, 5 minus 2 gives you 3 times 180 gives you 540 degrees. Therefore, the measures of each of these angles added together is equal to 540 degrees. Also note, it must be a convex polygon, meaning all the angles must be pointed outwards. There can't be any angle that caves in to the given polygon. There can't be any reflex angles where the interior angle measures greater than 180 degrees. Now, the Polygon exterior angle sum theorem says the sum of the exterior angle measures of a convex polygon is 360 degrees. Again, we're dealing with a convex polygon, meaning all the angles are pointed outward. In this case, we're talking about the exterior angle measures. So here, the exterior angles would be angle 1, angle 2, angle 3, angle 4, and angle 5. Those are exterior angles. They're created with one side of the polygon and the extension of an adjacent side. Now note, this theorem is much easier. It's just saying no matter how many sides this polygon has, the sum of the exterior angles, if you were to add up all of the exterior angles, it's always going to be 360 degrees. So the measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5 is equal to 360 degrees. How can that be? Well, if I were to shrink this pentagon, if I were to just continually shrink it, what happens? Well, it ends up just with a little point right here. So if I were to shrink this all the way down, all of these angle measures are still the same. We just have our pentagon is super tiny. Well, what do all these angles form? Well, they form a complete circle, right? If I were to add up all of these angles, that should give me a full circle, or 360 degrees. And that's why this is the case. If I were to shrink any figure all the way down like this, I end up getting that all of these exterior angles would then add up to a full circle, 360 degrees.
Hey, now it's example time!
Example 1 says find the sum of the measures of the interior angles of the following polygons. So here we have a convex heptagon. So what does that look like? Well, convex means all the angles are pointed outward. Heptagon means it has 7 sides. So it's going to look something like this. So we have a 7-sided figure and all the angles are pointed outward. So if I want to find the sum of the measures of the interior angles, remember there is a theorem that we just talked about. It's the Polygon interior angle sum theorem. And that just says I need to use the formula n minus 2 times 180 in order to find the sum of the measures of the interior angles of a polygon. So what do I plug in for n? Well, this is a heptagon, meaning it has 7 sides, and n is just the number of sides. So I take 7, plug it in for n, and I simplify. What's 7 minus 2? Because I have to do parentheses first. 7 minus 2 is going to give me 5. 5 times 180 is going to give me 900. Therefore, the sum of each of these angle measures in here, if I were to add them all up, I would get 900 degrees. Part B, we have a convex quadrilateral. So what does that look like? Well, convex, again, all the angles are pointed outward. Quadrilateral means it's got 4 sides. So it looks something like this, a rectangle. Sure, could have been a square, that's fine. I want to find the sum of the measures of the interior angles. So the Polygon interior angle sum theorem says the formula n minus 2 times 180 should give me the sum of the interior angle measures of this polygon. So what do I plug in for n? N is the number of sides. Here we have a quadrilateral. It's a four-sided figure. So I'm going to plug in 4 for n. What's 4 minus 2? That's 2. 2 times 180 is 360 degrees. Again, you have to do what's in the parentheses first based on your order of operations. If you remember PEMDAS, do the parentheses, then exponents, then you multiply or divide, then add or subtract.
Don't slip up. Time for you try.
Okay, doing the same thing here. So first we have a convex octagon. Convex means all the angles are going to be pointed outward. Octagon means it has 8 sides. So sure, a stop sign. Why not? It has 8 sides, all the angles are pointed outward. Next, I want to find the sum of the measures of the interior angles. So I want to find all of the measures of the angles in here added together. So what does that equal? Well, if I use the Polygon interior angle sum theorem, I just have to use the formula n minus 2, the quantity, times 180. What's n? N is the number of sides. So if we have an octagon, that would be an 8-sided figure. So I'm going to plug in 8 for n. To simplify this, I need to simplify what's inside the parentheses first based on my order of operations. So 8 minus 2 gives me 6. Then I can multiply the 6 times the 180 and I get 1080 or 1080 degrees. That's the sum of the interior angle measures of this given octagon. Now a convex nonagon. Convex, again, all the angles are pointed outward. Nonagon means it's a 9-sided figure. So it looks something like this. If I want to find the sum of the measures of the interior angles of this convex nonagon, I need to use the formula n minus 2, the quantity, times 180. N, again, is the number of sides. So in this figure, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. That's why it's a nonagon. We plug in 9 for n. 9 minus 2 gives me 7. 7 times 180 gives me 1,260 degrees. That's the sum of the interior angle measures of this convex nonagon. Now example 2 says find the measure of each interior angle of quadrilateral ABCD. So down here we have quadrilateral ABCD. To find the measure of each interior angle, it looks like we're already given the measure of angle B and the measure of angle C. We just need to figure out the measure of angle A and the measure of angle D. In order to do that, we have to find x. So how do we find x? Well, we need to set up an equation to solve for x. So how are all of these angles related? Well, it looks like these are congruent and these are congruent, but there's nothing in the problem that says that, and there's no arcs that show that, so we can't just set these equal to each other and solve for x. It doesn't work like that. Well, we do know that if I were to add up all of these angles, it should be equal to n minus 2 times 180, right? And if I were to say that the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equals whatever that n minus 2 times 180 is, then I can solve for x. So let's figure out first, what is that n minus 2 times 180? How do I find the sum of the measures of the interior angles of a quadrilateral, 4-sided figure? Well, again, I use n minus 2 times 180 and I plug in 4 for n. So what's 4 minus 2? That's 2. What's 2 times 180? That's 360. Therefore, the sum of the interior angle measures of this quadrilateral must be 360 degrees. Because I know that, I can now set up an equation to solve for x. All I have to do is take the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D and set that equal to 360 degrees, the sum of the measures of the interior angles of this quadrilateral. Now I plug in what I know. I know the measure of angle A is 9x, that goes in here. Measure of angle B is 70 degrees, that goes in here. Measure of angle C is 110 degrees, that goes in here. And the measure of angle D is 3x degrees. I now have an equation where I can solve for x. So let's simplify. I combine like terms. 9x plus 3x is going to give me 12x. 70 plus 110 is going to give me 180. I solve for x by subtracting 180 on both sides, dividing both sides by 12. I get x is equal to 15. Now, I found x, but that's not what I want to find. I want to find the measure of each interior angle. So I already know the measure of angle B and the measure of angle C, so let's just find the measure of angle A and the measure of angle D. So the measure of angle A is 9x degrees, so I'm going to take that x that I just found, 15, plug it in here. 9 times 15 gives me 135. Therefore, the measure of angle A is 135 degrees. Measure of angle D, we do the same thing. It's equal to 3x degrees, so I take 15, plug it in for x. 3 times 15 is going to give me 45. Therefore, the measure of angle D is 45 degrees. And you're done.
Yellow! It's a you try!
So we want to find the measure of each interior angle here. So we already know the measure of angle F. We just need the measure of angle E, measure of angle J, measure of angle H, and the measure of angle G. Again, to do this, we need to set up an equation that relates all of these angles. Well, we know, based on the Polygon interior angle sum theorem, if I were to add up all of these interior angle measures, it should equal n minus 2 times 180 degrees. So to figure out what that is for this figure, I use n minus 2 times 180 degrees, and in this case we have 1, 2, 3, 4, 5 sides. Therefore, it's a 5-sided figure. It's a pentagon. So I can plug in 5 for my n. To simplify this, I do what's in the parentheses first. 5 minus 2 gives me 3, times 180 gives me 540 degrees. I know that the sum of the interior angle measures of this convex pentagon is 540 degrees. So what I can do now is create an equation to solve for x. All I have to do is take the measure of angle E plus the measure of angle F plus the measure of angle G plus the measure of angle H plus the measure of angle J and add those up and set them equal to 540 degrees, the sum of the measures of the interior angles. To solve this, I plug in what I know. I know the measure of angle E is 4x minus 11. That goes in here. Measure of angle F is 142 degrees. That goes in here. Measure of angle G is 2x plus 14 degrees. That goes in here. Measure of angle H is 2x degrees, and so is the measure of angle J. So those go in there. I can now simplify this and solve for x. So to simplify, I combine like terms. 4x plus 2x plus 2x plus 2x gives me 10x. Negative 11 plus 142 plus 14 gives me 145. I then subtract 145 on both sides of the equation, divide both sides by 10, and I get x is equal to 39.5. That's not what I'm trying to find though. I'm trying to find the measures of the interior angles. So I have the measure of angle F, I just need to find the measures of all the other interior angles. Let's start with the measure of angle E. We know that's 4x minus 11, so I take what I found for x, 39.5, plug it in for x here, and I simplify. 4 times 39.5, then I subtract 11, and I get 147 degrees. Do the same thing for the measure of angle G. It's 2x plus 14, so I take 39.5, plug it in for x, and I simplify. 2 times 39.5 plus 14 is going to give me 93 degrees. Then I do the same things for the measure of angle J and H. They're the same, so I can just solve it one time. I don't need to solve it twice. So the measure of angle H is equal to the measure of angle J, which is equal to 2x degrees. I take 39.5, plug it in for x, and I simplify. 2 times 39.5 gives me 79 degrees. That's the measure of each of these angles. Clearly, the figure is not drawn to scale because these look like obtuse angles, and that's clearly an acute angle measure. So just know that this figure is not drawn to scale. Now example 3 says find the value of x in the diagram. Round answer to the nearest hundredth. So here we have a 1, 2, 3, 4, 5, 6-sided figure. That's a hexagon. And this time we are given the exterior angles. So the Polygon exterior angle sum theorem says if I were to add up the measures of all of the exterior angles of a given polygon, it's always equal to 360 degrees. So if I want to find x, all I have to do is create an equation where I add the exterior angle measures all together and set it equal to 360 degrees. So now all I have to do is combine like terms and solve for x. So let's combine like terms. X plus 2x plus x plus 3x plus x is going to give me 9x. Negative 2 plus 10 plus 18 is going to give me 26. I then solve for x by subtracting 26 on both sides, dividing both sides by 9, and I get x is equal to 37.11. Now again, we're rounding to the nearest hundredth, so make sure you know that's 2 decimal places.
Gonna peel back the layers for you try.
Okay, doing the same thing here, except this time we have a quadrilateral, a 4-sided figure. Since we need to find a, we need to set up an equation that relates all of these exterior angle measures. So we know the sum of the measures of the exterior angles of a polygon is equal to 360 degrees always. So now I can add up the measures of each of these exterior angles for this quadrilateral and set it equal to 360 degrees. Now I can combine like terms and solve for a. So a plus 3a plus 2a is going to give me 6a. 10 plus 31 minus 43 minus 11 is going to give me negative 13. I then solve for a by adding 13 to both sides and dividing both sides by 6, and I get a is equal to 62.17. Again, rounding to the nearest hundredth. Example 4 says find the measure of each interior and exterior angle of each regular polygon. So a regular polygon, remember, all of these sides are congruent and all of the interior angles are congruent. So if we know all of the interior angles are congruent, we know all of their measures are equal. Well, how's that going to help us here? if I know the sum of the measures of the interior angles of a polygon, and I know all of the angles are the same measure, then I can just take that sum and divide it by the number of angles, and that should give me one of the angle measures. So let's do that here. This is a pentagon, meaning that it has 5 sides, meaning that it also has 5 angles. So in for this n, we're going to put a 5. Now, how does that help us? Well, this up here gives us the sum of the interior angle measures of the pentagon, which 5 minus 2, we do that first, we get 3, multiply that by 180, we end up getting 540. Now, why are we dividing it by 5? Because this is a regular pentagon. And because it's a regular pentagon, that means that all of the interior angles are congruent. Their measures are the same. So I just take the sum of the measures of the interior angles and divide it by the number of angles, or the number of sides. It's the same number. So 540 divided by 5 is going to give you 108. So 108 degrees is going to be the measure of each interior angle in that regular pentagon. Now let's talk about the exterior angle measures. So here, we're going to find each exterior angle measure for the given regular pentagon. Now again, because it's a regular pentagon, all of the exterior angles will also be congruent. All of their measures will be equal. So we're going to take whatever the sum of the exterior angle measures is, which in this case, it's 360 degrees, right? It's 360 degrees for every polygon. So the sum of the exterior angles of any polygon is 360 degrees. If we want to find the measure of one exterior angle in a regular polygon, we just take that 360 degrees and divide by the number of angles, or the number of sides. It's the same number, it's n. So in this case, n is 5 because it's a pentagon. What's 360 degrees divided by 5? That's 72 degrees. So the measure of each exterior angle in this regular pentagon is 72 degrees. Now let's look at a decagon. A decagon has 10 sides. So if we want to find the measure of one interior angle of a regular decagon, we're going to do n minus 2 times 180 divided by n, the number of angles or number of sides. So what is our n in this case? Well, it's a decagon. So that's a 10-sided polygon. So we're going to plug in 10 for n here and here. 10 minus 2 is going to give us 8, and then 8 times 180 is going to give you 1,440. We then take that and divide it by 10, the number of sides or number of angles, same number, and we get 144 degrees. This means that the measure of one interior angle of a regular decagon, a decagon where all the sides and all the angles are congruent, is 144 degrees. Now let's find the exterior angle measure of a regular polygon. One exterior angle. To get that, we take the 360 degrees, because that's what the sum of the exterior angles are, and we divide that by the number of sides or number of angles. That's n. So 360 degrees divided by n. In this case, our n, it's a 10-sided figure, so we put 10. 360 divided by 10 is going to give you 36 degrees, meaning that each exterior angle of this regular decagon is going to be 36 degrees.
Petey says, tougher you try.
Okay, doing the same thing here. So first, we got a quadrilateral. If we want to find one interior angle measure of a regular quadrilateral, remember, regular means all the interior angles are going to have the same measure. They're all going to be congruent. So if I want to find one, I just use the sum of the interior angle measure formula, which is n minus 2 times 180, and divide that by the total number of angles, or the number of sides. It's the same number, n. So in this case, it's a quadrilateral, so it's a 4-sided figure. It's got 4 angles. We plug in 4 for n here and here. We then simplify this. 4 minus 2 is going to give you 2. Times 180 is going to give you 360. We then divide that by 4, which is the number of angles or the number of sides, and we get 360 degrees divided by 4 is 90 degrees, meaning that each interior angle of a regular quadrilateral is going to have a measure of 90 degrees. And that makes sense, right? A regular quadrilateral is just a square, and each angle measure within a square is 90 degrees. Makes sense. Now we want to find the measure of each exterior angle in a regular polygon. Remember, the sum of the exterior angles is 360 degrees for every polygon. We then divide that by the number of sides or number of angles, and that'll give us the measure of one exterior angle in a regular polygon. So there are 4 sides in this figure, so we plug in a 4 for n. We divide that, and we end up getting 90 degrees again. So in this case, the interior angles and exterior angles of a regular quadrilateral, a square, both equal 90 degrees. Now let's look at a hexagon. So a hexagon is a 6-sided figure. So if we want the measure of one interior angle in a regular hexagon, we're going to do n minus 2 times 180, which is the sum of the interior angles, and we divide that by the total number of sides or angles, n. So this is a 6-sided figure, which means it has 6 angles. So we plug in 6 for n here and here. We then simplify. 6 minus 2 is going to give you 4. 4 times 180 gives you 720. We divide that by 6, and we end up getting that each interior angle measure of a regular hexagon is 120 degrees. We then look at the exterior angle measure for a regular hexagon. So each exterior angle will also be congruent to one another. So we take the sum of the exterior angle measures, which in every polygon is 360 degrees. We divide that by the total number of sides or angles, that's n. And since it's a hexagon, that's 6. We divide 360 and 6, and we end up getting 60 degrees, which means the measure of each exterior angle in a regular hexagon is equal to 60 degrees. Now, example 5 says a skylight in a building in downtown Huntington Beach forms a regular octagon. Answer the following questions using the image below. So the first part says to find the sum of each interior angle of the skylight. Notice that it says find the sum of each interior angle. So if I want to figure out what is the sum of the measures of each interior angle of this given octagon, I use the formula n minus 2 times 180. Now, n minus 2 times 180, what is n? N is the total number of sides, or angles. So in this case, since it's a octagon, we're going to plug in 8 for our n. What's 8 minus 2? That's 6. What's 6 times 180? That is 1080 degrees. So that would be the sum of the measures of each interior angle in this regular octagon. Part B says if the perimeter of the skylight is 150.4 feet, find the length of one side. So this is a little different. The perimeter of the skylight is this, and we want to find the length of just one side. How do we do that? Well, if I want to find the length of one side, and I know that the perimeter is this, and I know that it's a regular octagon, remember regular means all the sides, and all of the angles are congruent. So if I know all these sides are congruent, all I have to do is take the perimeter and divide by the total number of sides. So the length of one side would be 150.4 feet divided by the total number of sides, n, which in this case is 8. So 150.4 divided by 8 is going to give you 18.8 feet. And that's the length of one side of this regular octagon. And you're done.